Hi there, Dominic here with an introduction to the Torus tool in Modo. You'll find that on the Basic tab, this icon over here. First I'm going to create a new item layer and hide these meshes. Left click on the torus, control click and drag to make uniform sized torus, and I'm going to press Control D. Control D, when the tool is active, resets your tool properties, and with the Torus tool it defaults to this position, these values, and the y-axis. So over here I can say x-axis, y-axis, or z-axis. I can give it a radius, a section, and a height value. I'm going to discuss this later, also the hole size later. The number of sides, for instance, to 3, and polygon typeset is subdiff right now by default. I'm going to set it to face. You can set it to face, subdiff, and Catmull Clark. I'm going to set it to face, which is more straightforward. By the way, if you don't see them purple handles, then go to your tool pipe, right click in the V column over here and set your tool to advanced. Then you'll see those bounding box dimensions, which is very useful with the Torus tool. So I was discussing the sides and the segments. 3 sides right now, number of segments for instance to 5, then I only have 5 segments like that. Segments for instance to 24, now I have 24 segments, number of sides like that, pretty straightforward. Again, give it a bulge value on the top and on the side. Now how do you see the top? Well, the top is actually kind of dependable on which axis you're on. So right now Z axis is selected, so this side and this side will be adjusted with the top. So when I set it for instance to 20, you see this side and this side gets more squared off with a higher value, and with the side it's the same but from another angle. So with the side for instance to 20, now it's more squared off like that. Now my number of sides is only 7, so it's not symmetrical, but when I set my sides to 12 for instance, you see you get more segments and they're all symmetrical. In 16, 20, 24, like that. All depends on the side bulge. For instance to 5, then you get that result, and this for instance also to 4 maybe, like that. So you can create really interesting shapes with the Torus tool. And of course, while the tool is active, I can simply use the widgets to scale, and note that it symmetrically scales on the other side, also like that and also like that. And I can also place, of course, with these handle widgets, or when I press the middle one, I can move in different axes. I'm going to reset my tool now, Control D, like that. So I've explained most of the ones that I wanted to explain, but over here we have ring radius, cross section height, and hole size, and these values, they are kind of interdependable of one another. So you see you have a cross section of 250 millimeters times 2 from hole size gives me a ring radius of 500 millimeters. Now I actually never use hole size. I always, when I want to fine-tune my bounding box measures, so these values over here, 1.5, 1.5 and 500 millimeters, when I want to adjust these, I do that via ring radius and cross section and height. First of all, the 500 millimeters, this is the doubling of the height. So if I look upon the torus like that, then I have a radius from the center to the outside of the torus along the y-axis, and it's important because right now it says y-axis, then the height is going to change the y-axis. Let me show you. So when I set it to 0.5, you see it has gotten a bit bigger on the y-axis, and right now, so it's 500 millimeters in that direction, and from here again 500 millimeters in that direction gives me 1 meter. And then we also have ring radius and cross section. I'm going to drop the tool, Control X to cut everything. I'm going to make these other layers back active that I had already created. So in the background layer I have a torus that I had created, and I'm going to show you how I created it. So Control click and drag and Control D to reset my work plane. I've entered a ring radius of 1 meter and a cross section value and a height of 100 millimeters and set it to face, and now you see I have a torus exactly like in my background. So drop the tool, Control Z to undo. And over here I've created some geometry representing some of these values. So the ring radius is like my blue geometry. Ring radius is the distance from the center of the torus to the center of the torus's geometry. So when I zoom in, this is a cross section of the torus I created. So the center of it to the center of the torus itself is your ring radius. Then we have cross section. This is represented by the red one. Now the cross section and height can be the same. When cross section and height are the same, then your geometry that is being created is perfectly circular, like the geometry in the background. So this one is actually the roundedness is perfectly circular, and this is because cross section height and cross section and height are exactly the same. I'm going to deselect it again too. And why do we have this separate radius? Because normally you would think, well, a circle, whether I go from here to there or from here to there or from here to there, the radius is the same. Well, with the torus you have the option to give it a different height, and I've already shown it to you. So right now I've drew my torus on the Z axis, so my height will be looked upon like that. Its height is 79.333 millimeters, resulting in the doubling gives me 194.667 millimeters. Again, the height is from the center to there plus from here to there, so this is kind of a radius, and to get the radius, to get the diameter of a radius, you have to double it. So when I set this to, for instance, 1, sorry, that's a bit much, to 0.2 for instance, 200 millimeters, you see, then my height is 400 millimeters, like that. And of course it depends on which axis you are working. So when I set it to the Y, now when I set my height to 0.2, then you see over here the bounding box height is 400 millimeters. But to calculate the other bounding box values, you have to take the ring radius and the cross section into account. So let's say I want the bounding box value to be 2 meters, then I have to divide it, those 2 meters by 2, it gives me 1 meter, and I have to take the cross section into account. Let's say I am happy with a cross section of 200 millimeters, which will give me a 400 millimeter diameter of the geometry, and I wanted this to be 1 meter, so divided by 2 is 500 millimeters, and 500 millimeters minus 200 millimeters is 300 millimeters, and as you can see now I have 1 meter, 1 meter. Can be a bit confusing, and maybe you will thinking, what is he talking about? But it's actually something we will have to do if you want to create exact dimensions with the Torus tool. So again, manipulating them interactively is very straightforward. You can just click and drag on these icons, or control click on the widgets here to scale uniformly, or left click on these widgets to scale on a plane like that and move it, and all of that, no problem. But once you want the exact dimensions for the bounding box, well, the height will control the axis height, as if you will. So if I set it to 0.5, then it will be 1 meter because it's doubled. You have a diameter from here to there and a diameter from here to there, so it's twice this value, which gives me 1 meter in this case. And to calculate the other dimensions, for instance, when I want it to be 2.5 meters and I want a cross section of, for instance, with a diameter of 200 millimeters, then I enter 100 millimeters over here. Now my diameter is 200 millimeters, the radius is 100 millimeters, and I wanted 2.5, so 2.5 divided by 2 is 1.25, minus 100 is 1.15, and you see how I have 2.5 meters, 2.5 meters, and 1 meter. And that's kind of how you go about setting the dimensions to an exact amount for the Torus tool. Of course, now I've used values like 1, 2, 3 of 2.5, which are pretty straightforward to use. Sometimes if you have decimals, if you have a dimension that needs decimals, then you will have to write it down and do it with a calculator. But I hope the idea comes across. I'm going to Ctrl Z to undo that. To calculate the exact bounding box distances, you have to take the ring radius into account, so from the center of the torus to the center of its geometry, and add to that the radius of the cross section, and then multiply that by 2 for the other side, and then you get the bounding box dimension in that side, and the bounding box dimension for the height. So the height, when it's y, then the y-axis is the height. When it's z, then the z-axis is the height. When it's x, then the x-axis becomes the height. That is something you simply have to divide by 2. So if you want it to be 1 meter, then you have to enter 1.5, and then your height will be 1 meter. So I hope it wasn't too confusing. I think I've covered everything I wanted to cover about the Torus tool. Use with it and play with it. It becomes more straightforward once you start doing it yourself. You can also choose, of course, to create a geometry with other tools. That's perfectly possible, to create Torus-like tools, Torus-like geometry with other modo tools. It will involve a few more steps, but once you understand these concepts, you have your ring radius from the center to the center of the geometry, and your cross section, which is being added to that to get your bounding box dimension, and then doubled for the other side, and this gives you your complete bounding box dimension. And then the height, depending on which axis you are looking. If you want it to be, you have to divide it by 2. So if you want it to be 1 meter, you set 500 millimeters, and then your height will be 1 meter in total. So hope you've understood everything. Hope you find it useful. This was Dominic. Bye for now.